Chapter 15: Mineral Resources and Environment. We talked about minerals and rock cycle in previous chapter. And what is a mineral? If you recall, what is a mineral? Is a naturally forming, inorganically processing, and homogeneous substances with fixed atomic structure and fixed chemical formula, and they are considered to be solids. So in with the exception with mercury, so most of the other minerals, all of the other minerals are solids. So by definition, mineral is a chemical compound, but it's just not a chemical compound. It's also having these five requirements to be fulfilled in order to be a mineral. So mineral is considered as a resource because it is important economically, and even if you look around yourself, most of the things that you see around you is made out based upon a mineral. For example, if you look at your window, it's a glass that's made upon based on the quartz, that's a mineral. And also if you look at your wall, so it's probably wood, but the wood is hydrocarbon, it's not a mineral. But if you look at the on the floor that you're sitting on, you're standing on, that is mainly you have cement, you have clay, sand, um, and other particles. Those are either minerals or constituents of minerals. So minerals and human use. So minerals are backbone of modern societies. The availability of mineral resources as a measure of the wealth of the society. It's important in people's daily life as well as in overall economy. So mineral resources are non-renewable. So this is why we need to protect them and use them wisely. The common use of mineral product: gold, mercury, lead, copper, iron, aluminum. So these are the major elements, or they are native elements. For example, copper and lead, or the gold are native elements, but lead can come as a sulfide. So we talked about these different mineral groups. However, these are the approximate concentration factors of selected metals, the necessary before mining is economically feasible. So gold, mercury, lead, copper, iron, aluminum. So these are the major metals that people mine for, the people looking for economically. Mineral resources: usable economic commodity extracted from naturally formed material, be they elements, compounds, minerals, or rocks. These are known as the mineral resources. This definition is important. You should remember this definition. Reserve is a portion of a resource that is identified and currently available to be extracted legally. So that's called a reserve. Defining factors are geologic, technological, economic, and legal factors. Mineral resources and reserves. So economic or marginal economic or sub-economic. These are the three categories, and whether we identified or unidentified. This is the other portions, other categories in the other side of the chart, and you can see the increasing degree of geologic assurance towards the left side of the chart, and the reserves versus marginal reserves, and hypothetical resources and speculative resources. So those are undiscovered and unidentified. So the identified resources, if they're economic, then they call reserves. The marginal reserves, they're marginally economic. And resources are, when it becomes sub-economic resources, those are identified but sub-economic. So these terms are pretty new, but you need to understand what this means. And the types of mineral resources: based on how we use them, the materials for metal production and technology, construction materials, agricultural industries like fertilizers, mineral resources for chemical industry and other like precious gemstones, cosmetics, food, etc. So energy, mineral resources. So the based on how we use them, there are different types of mineral resources that we can talk about. So non-renewable resources. The minerals they are not producing as the same rate that they are using. So finite amount of mineral resources and growing demands of the resources. So supply shortage due to the growing global industrialization, with more developed countries consuming disproportionate share of mineral resources. The erratic distribution of the resources and uneven consumption of the resources is a problem. So highly developed countries use the most of the resources compared to the developing countries. So that's a problem. Responses to limited availability, so we need to find more sources, we need to look for more and more minerals. There are a number of minerals, number of elements that we have not discovered yet. They're to be discovered in somewhere on the earth, so we need to look for more sources and find substitute. So your substitute need to be environmental friendly as well, so you need to be careful when you're looking for this substitute. However, that kind of solve the problem. And recycling the minerals, and use less and make more efficient use of what is available. So that's another important thing that we should keep in mind when we talk about the the response to limited availability. And here is the kimberlite pipe. What is kimberlite pipe means? The kimberlite pipes are the pipes that the diamonds gonna come to the surface. So these are very important economically. So these massive kimberlite pipe, they bringing the deep-seated diamond to the ground. So here is this open pit mining, this kimberlite pipe, and looking for the diamond basically. And the metallic core, the geology of mineral resources. What is metallic core? The useful metallic minerals that can be mined for profit. So that's metallic ore. The mining potential depending upon technology, economics, and politics, with an emphasis on profitability, technological visibility, and demands. A consideration factor is also important. The consideration necessary for profitable mining, for example, for gold is about 5,000. The variable with types of metals and variable over time, depending on the demand. Genesis of mineral resources. In this table, you can see evaporite and brine resources of the United States expressed in years of supply at current rates of domestic consumption. And when we talk about the minerals, we briefly talked about how these different minerals are forming and what are the places that you can expect to see the minerals. The plate tectonics play a major role forming these precious metals and minerals. Plate tectonic boundaries related to the origins of many ore deposits like iron, gold, copper, and mercury. Plate tectonic processes, high temperature, high pressure, and partial melting associated most of the cases. For example, if you're thinking about the subduction zones or the thrust faults, where you have this uh, the high pressure, high temperature conditions can promote the partial melting of existing minerals and forming new minerals. And the plate tectonic processes promoting release and enrichment of metals along plate boundaries. So ore deposit at divergent boundaries is related to the migration or the movement of ocean water. Ore deposits at convergent boundaries related to partial melting of seawater, saturated rocks of the oceanic lithosphere in a subduction zone. If you recall about convergent boundaries, if you think about subduction zone, the oceanic lithosphere sinking underneath the continental lithosphere, forming this subduction zone. Danger in oversimplification, not all directly related to the plate boundaries. So you cannot oversimplify because not all of these ore deposits are directly related to the plate boundaries. There are other places you can expect to see these ore deposits where you will not see any plate boundary nearby. Mineral sources on the bottom of the ocean are vast. So other places, when we think about the other places where you can see the minerals and precious elements, the bottom of the ocean. Sulfide deposits, especially the massive sulfide deposits containing zinc, copper, iron, and trace amounts of silver, are produced at the black smokers along the oceanic ridges, from which the hot, dark-colored, mineral-rich water emerges at hot springs. So these are hydrothermal conditions. Manganese oxide nodules over vast areas of deep ocean floor containing manganese and iron with secondary copper, nickel, and cobalt, most abundant in where sediment is at a minimum, generally at depth of 5 to 7 kilometers, and cobalt enriched manganese crust present in the mid and southwest Pacific on flanks of seamounts, volcanic ridges, and islands. Mineral resources and environmental impact. Environmental impact from mineral exploration and testing, from mineral mining, from mineral resources refining, from mineral waste disposal. So any of these going to affect the environment. If you think about the mineral mining or exploration, so when you talk about this open pit mining, you can, if you've been one of these open pit mining, or the 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 site where you're gonna see this, the mining for ore deposits or mining for metals, mining for minerals, you will see how much damage, that you can clearly see the damage that is causing towards the environment. The impact depend on many factors. So the mining procedures, whether it's an open pit, or whether it's the what type of engineering technique, or the what kind of the the blasting techniques that they use to do this mining, and hydrologic conditions, where the water table, is there any potential contamination, and climatic factors, what is the rainfall, what is the rate of rainfall, and if there are any droughts, or what is the climatic conditions. Types of rocks and soils is also important. What type of rock that you're looking at, whether these are granites, or whether these are sandstones, whether these are just soils. Topography, the relief, with the slopey area, or the still is like the gentle slope versus steep slope. Likewise, you need to pay attention to those factors when we talk about the impact on the environment. Mineral exploration and testing, the surface mapping, geochemical, geophysical, and remote sensing data collection is the first step, and then the test drilling. And impact, the generally minimal impact, more planning and care needed for sensitive areas like arid wetlands and permafrost areas. You need more caring. The general impact, the direct impact on land, water, air, and biological environment, an indirect impact on the environment, topographic effect, transportation of materials, and impact on social environment, increase the demands for housing and services, especially when you have more and more job opportunities, then you have more impact on the social environment, increasing the demand for housing and services, because this area is going to be developing all the road system to carry or transport these materials. So the environment is going to be changed with this kind of process, like mineral extraction process. And the land disturbances from access, surface mining, it's more economical but more direct environmental effects. The waste from mines, 40% of the mining area for waste disposal. Mining waste, 40% of all solid waste. Special mining, example, chemical leaching from gold mining, that needs to be paid attention because that can contaminate the groundwater table. So that needs to be understand properly. Mining acid drainage during mining and post mining, that is important. So that's creating a lot of metals and acidic conditions where you can promote formation of acid mine drainage, which is another environmental issue. And the water pollution, such as smelting emissions of sulfur dioxide and potential acid rains because of that. And the biological environment, so the changes within the habitats, and some how this is going to affect the animals and plants. The impact of mineral extraction and processes, this is one of the pictures. We talked about this, but this is an open pit mining site, and you can see how the environment has been changed. Water pollution, the trace elements leaching out into water such as cadmium, cobalt, copper, lead, molybdenum, zinc. So flooding of abandoned mine and acid mine drainage from tailing, acidic and toxic mining wastewater. So these are considered as the components of water pollution right after the mining exploration. The other pollutions, air pollution. The both extraction and processing operations have adverse effects on air quality. Smelting has released enormous quantities of pollutants, toxic gases from abandoned mines. Pollution to overall biological environment. So physical and chemical changes in the land, soil, water and air associated with mining directly and indirectly affect the biological environment. Again, the mining and toxicity is something to think about. Maybe it's short term or long term, some adverse health effects. So itai disease, it's a chronicle and painful. Itai means ouch ouch. So attacks bones. The bones and tissues of victims were examined and found to contain large concentrations of zinc, lead, and cadmium. So, mercury and gold mining could do the gold particles cling to the liquid metal mercury, making recovery of the gold easy. So, estimated 4,500 metric tons of mercury was lost into the environment from 1850s to 1880s in California. This is not knowledge and technology transfer. So the developed countries to developing countries, you need to transfer the knowledge about these adverse effects and try to minimize the impact of mining, because the developed countries are more knowledgeable than the developing countries. So you need to transfer this knowledge and the technology, because developing countries, they may be using very traditional technology where you're gonna produce a lot of waste. At the same time, this is the waste management is not that good, so you need to make them aware about that. And environmental regulations, the forbid bad mining practices. Clean Air Act needs to be in practice, and on and off-site treatment of waste uh, needs to be done. And land reclamation, it's about 50% of land used in mining industry reclaimed. And use of new biotechnology in mining, like bioxidation, bioleaching, biosorption, genetic engineering. So you can use some biology like microbes in order to get rid of this waste by using them like in a useful way. You can do this and use this in a different process. And so biooxidation, bioleaching, so you're using microbes in order to eat this waste, in other words. So that's gonna reduce the impact of mining. Recycling mineral resources. Why recycle? Consider the impact of the waste. So the toxic to humans and dangerous to natural ecosystem, and degradation of air, water and soil, and use of land for disposal, and aesthetically undesirable. So because of these reasons, we need to recycle the mineral resources. Recycling mineral resources, so basically you explore and resource extraction and refining process and metals or chemicals or elements, and they become products like appliances, cars or structures, and they can be recycled and going back to the process. And also most in each different process, right here you can see the arrows coming towards the disposal. So this disposal is where the waste disposal, this is where you need to think about this is going to go back to the earth, and how this is going to go back to the earth. This needs to be treated before it's going back to the earth. The waste contains recyclable materials. This saves energy, money, land, raw minerals, resources from more mining. Saves energy and money when recycling instead of refining raw or material. Recycling has been proven to be profitable and workable. So this is something other countries should be following, the developed countries. Most recycled metals, iron and steel, 90% by weight. One third as much energy needed to produce steel from recycled scrap and from original ore. So in 2006, the total value of recycled steel in United States was about $18.5 billion. Recycling of iron and steel amounted to approximately 50%. sustainability. What that means? Long-term strategy for consuming the resources. So you have to use the resources, but we have limited resources. So we have to use our resources wisely. So that's the idea. They find an alternate material for the metals. For example, glass, fiber, cable for copper wires. So likewise, you need to find some substitute or the alternatives that can minimize the issue. So these are some of the critical thinking questions, and if you do have any questions, you're certainly welcome to email me or post your question in the discussion board in the Blackboard. That's the end of the chapter 15.